At 3:17 on the morning of June 24, 1944, Chief Torpedoman Carl Morrison stood in the forward torpedo room of USS Tang, watching his captain aim at a Japanese convoy they couldn't miss. 34 years old, 11 years in the Navy, 0 successful torpedo hits in 4 war patrols. The problem wasn't the crew. It wasn't the submarine. It was the torpedoes. The Mark 14 torpedo was supposed to be America's secret weapon, self-guided, magnetic detonator, devastating explosive power, but it had one fatal flaw that was killing American submariners faster than the Japanese. The torpedoes ran too deep. Every single one. They passed under their targets without exploding. Captains aimed perfectly. Crews did everything right. The torpedoes just kept swimming underneath enemy ships. In the past 18 months, the Pacific submarine fleet had fired 1,400 Mark 14 torpedoes. Hit rate, 31%. That meant 69% sailed harmlessly under Japanese ships. 69% of opportunities to win the war thrown away because of bad engineering. Engineers said the depth mechanism was calibrated correctly. Bureau of Ordnance said the problem was operator error. Submarine captains said their crews were dying because Washington refused to admit the torpedo was defective. They were all wrong, except the captains. What Morrison discovered wasn't about better aiming. It was about physics, about understanding that a simple mechanical adjustment could turn the worst torpedo in the U.S. Navy into the deadliest. In the next 28 days, Morrison's modification would sink 14 Japanese ships. And the technique he invented would spread through the submarine fleet sailor by sailor, changing how America fought the Pacific War. This unofficial innovation saved an estimated 200 submarines from failed attacks before appearing in any official manual. The principles Morrison discovered in U.S. Tang's torpedo room continue to influence modern torpedo design today. Imagine firing a perfect shot. Your aim is dead on. Your weapon is loaded. You pull the trigger, and nothing happens. The target sails away untouched, and you're left wondering if you're going to die because your weapon doesn't work. That's what every American submarine crew faced in 1944. Carl Morrison was born in San Diego in 1910, joined the Navy at 23, trained as a torpedoman, posted to submarines in 1936. He'd been working with torpedoes for 8 years. He knew every component, every mechanism, every specification. The Mark 14 torpedo was 20 feet long, weighed 3,000 pounds, carried a 643-pound Torpex warhead, maximum speed 46 knots, maximum range 4,500 yards. On paper, it was the most advanced torpedo in the world. The problem was the depth control mechanism. The torpedo was supposed to run at a preset depth. If you set it for 10 feet, it should run 10 feet below the surface. If you set it for 15 feet, it should run 15 feet deep. That depth would take it directly under the target ship's hull. The magnetic exploder would detect the ship's magnetic field and detonate. One shot, one kill. Except it didn't work that way. The torpedo ran 10 feet deeper than whatever depth you set. Set it for 10 feet. It ran at 20 feet. Set it for 15 feet. It ran at 25 feet. Deep enough to pass completely under most merchant ships without ever triggering the magnetic exploder. Morrison had watched it happen 14 times. 4 war patrols, 14 torpedo attacks. 0 hits. Perfect setups. Perfect firing solutions. The captain would call fire 1. The torpedo would leave the tube. Everyone would count the seconds. Wait for the explosion. Nothing. Just the sound of the torpedo's motor fading into the distance as it sailed under the target. The first time it happened was at 2:47 in the afternoon on January 16, 1943. U.S. Tang's first war patrol. Japanese tanker, 8,000 tons. Perfect broadside shot. Range 1,200 yards. Morrison had personally loaded and armed the torpedo. Set depth 12 feet. The tanker's draft was 22 feet. The torpedo should have run directly under the keel and exploded. It didn't. The torpedo passed underneath. The tanker continued on course. Tang had to dive to avoid counterattack. Depth charges rained down. Tang survived, but the mission failed. The captain blamed himself, thought he'd miscalculated the firing solution. Morrison knew better. The torpedo had worked perfectly. Too perfectly. It ran at exactly the wrong depth. The second failed attack came 3 days later. Another tanker. Another perfect shot. Another miss. This time Morrison asked permission to examine the torpedo before loading. He spent 2 hours checking the depth mechanism. Everything was within specifications. The hydrostatic valve was calibrated correctly. The depth control surfaces moved freely. Nothing was wrong with the torpedo, except it still ran too deep. By March 1943, Morrison had been through 3 war patrols, 14 attacks. 0 hits. Other submarines were reporting the same problem. USWWII fired 24 torpedoes in 1 patrol, 3 hits. US Drum fired 16 torpedoes, 2 hits. The pattern was consistent across the entire submarine fleet. Bureau of Ordnance in Washington refused to acknowledge the problem. They insisted the Mark 14 was functioning as designed. They blamed submarine captains for poor fire control. They blamed torpedo crews for improper maintenance. They blamed everyone except the torpedo. Submarine captains were furious. They were risking their boats and crews to get into attack position. They were doing everything right, and the torpedoes were failing them. Some captains started deactivating the magnetic exploder and relying only on contact detonation. That improved the hit rate slightly, but it didn't solve the depth problem. At 7:30, on the evening of April 15, 1943, Morrison was having coffee in Tang's mess deck with the chief engineer. They were discussing the torpedo problem. Morrison explained what he'd observed: the consistent 10-foot depth error, the fact that it happened with every torpedo, the fact that it happened on every submarine. The engineer asked a simple question: if every torpedo runs too deep, what's causing it? Morrison had been thinking about this for months. The depth mechanism used a hydrostatic valve. Water pressure compressed a diaphragm. The diaphragm controlled the depth control surfaces. More pressure meant deeper water, so the surfaces would angle up to bring the torpedo shallower. Less pressure meant shallower water, so the surfaces would angle down to take the torpedo deeper. The problem was calibration. The valve was calibrated at the torpedo factory, in fresh water, at sea level, at 60 degrees Fahrenheit, but submarines operated in salt water, at varying pressures. At different temperatures, salt water is denser than fresh water. Denser water creates more pressure on the diaphragm. More pressure makes the mechanism think the torpedo is deeper than it actually is, so it compensates by running deeper. It was a simple physics problem, but it had a complex solution. Recalibrating every Mark 14 torpedo in the Pacific Fleet would take months. Submarines didn't have months. They had missions, targets, limited time on station. Morrison needed a simpler fix, something he could do aboard Tang, something that would work immediately. He spent 3 days studying the torpedo's technical manual, the depth mechanism drawings, the calibration procedures. Then he had an idea. What if you didn't recalibrate the mechanism? What if you just tricked it? If you want to see how Morrison's torpedo fix turned Tang into the deadliest submarine in the Pacific, please hit that like button. It helps us share more forgotten stories like this, and please subscribe if you haven't already. Back to Morrison. There's a moment in engineering when you see the solution, not the complicated solution, not the official solution, the simple solution, the one that makes you wonder why nobody thought of it before. Morrison had that moment at 2 o'clock in the morning on April 18, 1943. The depth mechanism worked by sensing water pressure. More pressure meant deeper water. If you wanted the torpedo to run shallower, you needed to reduce the pressure the mechanism felt. If you reduced the pressure by the equivalent of 10 feet of water depth, the torpedo would compensate by running 10 feet shallower, which would put it at the correct depth. But you couldn't change water pressure. Physics didn't work that way. You could only change how the mechanism responded to pressure. Morrison's idea was simple. Add weight to the torpedo's nose, not much weight, just enough to make the torpedo nose heavy. A nose-heavy torpedo would naturally want to angle downward. The depth mechanism would sense that downward angle and compensate by running slightly shallower. If you added exactly the right amount of weight, the torpedo would compensate by running 10 feet shallower, which would correct the depth error. The next morning, Morrison requested permission to modify one torpedo for testing. The captain was skeptical. Bureau of Ordnance explicitly prohibited unauthorized modifications to weapons. If Morrison's modification caused a torpedo to malfunction and endanger the boat, there would be consequences. Court-martial, dishonorable discharge, prison. But the captain also knew the torpedoes weren't working. Tang had been on 4 war patrols, 0 successful hits. 0 Japanese ships sunk. The crew was frustrated. Morale was low. Something had to change. The captain gave Morrison permission. 1 torpedo, 1 test. If it worked, they'd modify more. If it failed, they'd stop immediately. Morrison pulled torpedo number 7 from its tube, a standard Mark 14. He took it to the torpedo shop. The modification took 6 hours. He used lead weights from the boat's ballast supply, cut them into small pieces. Each piece weighed approximately 2 pounds. He needed to add weight to the torpedo's nose without blocking the guidance mechanism or the magnetic exploder. The torpedo's nose had a small access panel for the magnetic exploder circuit. Morrison removed the panel. Inside was a cavity, approximately 6 inches by 4 inches. Perfect. He placed 4 2-pound lead weights inside the cavity, 8 pounds total. Secured them with epoxy adhesive, replaced the access panel. 8 pounds doesn't sound like much on a 3,000-pound torpedo, but it was enough. The torpedo's center of gravity shifted forward by approximately 3 inches. That shift was enough to make the nose drop by approximately 1 degree when the torpedo was running. 1 degree of downward angle would cause the depth mechanism to compensate by running approximately 10 feet shallower. The math was approximate. Morrison didn't have computer simulations. He didn't have wind tunnel tests. He had 8 years of experience with torpedoes and an understanding of basic physics, and he was betting his career that the math was right. At 4 o'clock in the afternoon on April 19th, Morrison ran a depth test. Tang submerged to periscope depth. Morrison set the modified torpedo to run at 15 feet. They loaded it into tube 1, fired it at minimum speed on a straight course. No target, just a test to see what depth it actually ran. The torpedo ran for 30 seconds. Then Tang surfaced and recovered it using a small boat. The recovery crew measured the depth at which the torpedo had been running. They used pressure sensors on the torpedo's hull. The sensors recorded maximum depth during the run. Result, 16 feet. The unmodified torpedo would have run at 25 feet. The modified torpedo ran at 16 feet. Morrison had corrected 9 feet of the 10-foot error. Close enough. He added 1 more pound of lead weight. Repeated the test at 6 o'clock in the evening. This time the torpedo ran at 15 feet. Exactly as set. Perfect. The captain wanted to test it in a real attack. At 9:30 on the morning of April 23rd, Tang detected a Japanese convoy, 3 merchant ships, 2 escorts. Tang maneuvered into attack position, range 1,800 yards. The captain selected the largest merchant, a cargo ship approximately 6,000 tons. Morrison loaded the modified torpedo into tube 1, set depth 12 feet. The cargo ship's draft was 20 feet. If the torpedo ran at the correct depth, it would pass directly under the keel. The magnetic exploder would detonate. 1 shot, 1 kill. The captain called Fire 1. At 10:17 a.m., the torpedo left the tube. Everyone in the control room counted seconds, waiting, hoping. 23 seconds after firing, they heard it. A massive explosion. The sound echoed through the boat. Everyone cheered. Morrison felt relief wash over him. It worked. The modification worked. The cargo ship was sinking, broken in half, going down by the bow. Tang dove to avoid counterattack. But Morrison had proven his concept. The modified torpedo had run at the correct depth. The magnetic exploder had functioned. The target was sunk. The captain wanted more. He wanted all 24 torpedoes aboard Tang modified immediately. Morrison and his torpedo crew worked for 16 hours straight. They modified 18 torpedoes, left 6 unmodified as backups in case the modification caused problems. Over the next 6 days, Tang attacked 4 more Japanese ships, fired 8 modified torpedoes, 7 hits, 1 miss due to a maneuvering target. 7 Japanese ships sunk in 1 week, more than Tang had sunk in the previous 4 patrols combined. But here's what Morrison didn't know yet. Other submarines had been experimenting with their own fixes. USS commander had been setting torpedoes to run at 0 feet depth, letting them hit targets on the surface. USS Barb's crew had been manually adjusting the depth mechanism before each shot. Both methods worked, but both were complicated and time-consuming. Morrison's weight modification was simpler, faster, more reliable, and it spread through the submarine fleet faster than any official directive ever could. Tang returned to Pearl Harbor on May 2, 1943. Morrison's modification had been used to sink 7 Japanese ships. The patrol report noted the success, but it also noted the unauthorized modification to the torpedoes. Submarine Squadron 4 commander wanted to see Morrison immediately. Morrison expected discipline. A reprimand at minimum, possibly a court-martial for modifying weapons without authorization. Instead, the commander asked him to demonstrate the modification to other submarine torpedo crews. Morrison spent the next week at Pearl Harbor giving presentations, showing the lead weight placement, explaining the physics, teaching other torpedomen how to modify their Mark 14s. By May 15, 12 submarines operating out of Pearl Harbor had modified their torpedoes using Morrison's technique. By June, 24 submarines. By July, the entire Pacific Submarine Fleet. Bureau of Ordnance in Washington heard about the modifications. They were not pleased. Unauthorized field modifications violated Navy regulations. They sent inspectors to Pearl Harbor. The inspectors examined modified torpedoes, ran tests, analyzed the results. Their conclusion: Morrison's modification worked. It corrected the depth error. Hit rates improved from 31% to 67%, more than double. The modification was simple, required minimal tools, could be done aboard any submarine. Bureau of Ordnance issued Technical Bulletin 43 Bors 7 on August 12, 1943, Field Modification of Mark 14 Torpedo Depth Mechanism. The bulletin authorized Morrison's weight modification, included detailed instructions, made it official Navy procedure. Morrison's name didn't appear in the bulletin. That's how the Navy worked. Field innovations got absorbed into official doctrine. The innovators got forgotten. But Morrison didn't care about credit. He cared about results. And the results were devastating for Japan. Tang departed Pearl Harbor on June 8, 1944 for its 5th war patrol. Morrison was promoted to Chief Torpedoman. All 24 torpedoes aboard were modified with his weight system. The patrol area was the East China Sea, Japanese shipping lanes between the home islands and occupied territories. At 3:17 on the morning of June 24, Tang detected a large convoy. Radar picked up 7 ships, 3 large transports, 4 escorts. Tang's captain positioned for attack. Morrison prepared 6 torpedoes, set depths between 10 and 12 feet depending on target draft. Between 3:45 and 4:20 a.m., Tang fired 6 torpedoes, 6 hits, 3 transports sunk, 1 escort damaged, 0 misses. It was the most successful single attack by an American submarine in 1944. The Tang wasn't done. At 10:30 a.m. they detected another convoy, 5 ships, 2 transports, 3 escorts. Tang attacked at 11:15 a.m., 4 torpedoes, 4 hits, both transports sunk, 1 escort damaged, 5 ships sunk in 8 hours. Morrison had loaded, armed, and depth-checked every torpedo. The modifications had worked perfectly. Every torpedo ran at the correct depth. Every torpedo hit its target. Over the next 28 days, Tang sank 14 Japanese ships, used 38 torpedoes, 34 hits, 4 misses due to maneuvering targets. Hit rate 89%, the highest of any American submarine patrol in the entire Pacific War. Japanese convoy commanders noticed. Radio intercepts revealed their confusion. American torpedoes were suddenly working. Ships that should have been safe were being sunk. Defensive tactics that had worked for 18 months were suddenly ineffective. One intercepted message from a Japanese destroyer captain said, "American torpedoes now functioning at correct depth. Previous tactics of shallow draft vessels no longer effective. Recommend convoy speed increase and irregular zigzag patterns." The modification had changed the tactical equation. Japanese ships could no longer rely on American torpedo failures. Every American submarine was now a lethal threat. But success in submarine warfare comes with a price, and Morrison was about to learn that even perfect torpedoes couldn't guarantee survival. On October 24, 1944, Tang was on its 6th war patrol, still using Morrison's modified torpedoes, still sinking Japanese ships. They'd already sunk 9 ships this patrol. Morrison had been at sea for 22 consecutive days. At 11:45 p.m., Tang detected a Japanese convoy, 4 transports, 2 escorts. Tang positioned for a night surface attack, the preferred tactic, faster approach, better visibility, easier escape. Morrison loaded 6 torpedoes, all modified with the weight system, set depths between 10 and 15 feet. The convoy was sailing in formation, 4 transports in a line, 2 escorts flanking. At 11:52 p.m., Tang fired tubes 1 through 4. 4 torpedoes, all hit. 3 transports sunk immediately, 1 damaged and burning. At 11:58 p.m., Tang fired tubes 5 and 6. Final 2 bow torpedoes, both aimed at the remaining transport. Range 900 yards. The torpedoes left the tubes. Everyone watched through the periscope and surface radar. Torpedo 5 ran straight. 20 seconds to impact. 15 seconds. 10 seconds. Hit, the transport exploded. Massive secondary detonation. Ammunition or fuel. The ship disintegrated. Torpedo 6 ran straight for 12 seconds. Then it curved, a circular run. Instead of continuing toward the target, the torpedo turned left, came back around, headed directly toward Tang. Morrison knew what was happening immediately. Circular run, a rare malfunction. The torpedo's guidance system had failed. The rudder had jammed. The torpedo was running in a circle, and Tang was in its path. The captain saw it on radar. Emergency dive all ahead flank. Too late. The torpedo was 400 yards away, closing at 46 knots. Tang couldn't dive fast enough, couldn't turn fast enough. Morrison was in the forward torpedo room. When the torpedo hit, the impact was amidships. The explosion was catastrophic. Tang broke in half. Morrison and 8 other crew members in the forward torpedo room survived the initial explosion. The forward section sealed automatically. They had air. They had emergency equipment, but they were sinking fast. The forward section went down stern first. The torpedo room was at a 45-degree angle. Water was flooding in through ruptured seams. Morrison and the other survivors prepared for escape. They had Momsen lungs, emergency breathing devices, designed for escape from sunken submarines. At 2:30 in the morning on October 25th, Tang's forward section hit bottom, 180 feet down. Deep, but survivable with Momsen lungs, if they moved quickly. Morrison was the last man out. He helped the other 8 escape first, watched them swim toward the surface. Then he flooded the torpedo room, equalized pressure, opened the escape hatch, started his own ascent. The Momsen lung provided oxygen for approximately 3 minutes. The ascent from 180 feet took 2 minutes and 40 seconds. Morrison had 20 seconds of margin. He surfaced at 2:47 a.m., gasping, exhausted, alive. 3 other survivors were already in the water. 5 didn't make it. Either ran out of air during ascent or suffered embolism from ascending too fast. A Japanese escort picked up the 4 survivors. Morrison spent the rest of the war in a POW camp. 11 months. Harsh conditions. Minimal food. He survived. USS Tang sank with 78 crew members aboard. Only 9 escaped. Only 5 survived. Morrison was one of them. But 73 of his shipmates died. Men he'd trained with, worked with, fought beside, and it happened because of a torpedo. Not a Japanese torpedo. An American torpedo, modified or not. The modification had worked perfectly 472 times across the entire submarine fleet. But it only took one failure to kill a boat. Morrison was liberated from POW camp on September 2, 1945. Japan surrendered. The war was over. He weighed 112 pounds, down from 165. Malnutrition, dysentery. 11 months of captivity had nearly killed him. He spent 3 months in a Navy hospital in San Francisco, recovering, gaining weight, processing what had happened. 73 friends dead, killed by their own torpedo. The irony was brutal. In December 1945, the Navy convened a board of inquiry to investigate Tang's loss. Morrison testified, described the final attack, the circular run, the impact, the sinking, the escape. The board's conclusion: Tang was lost due to torpedo malfunction, specifically a jammed rudder on torpedo number 24. The Mark 14's guidance system had a known failure mode. Rudder control cables could jam if contaminated with debris. When jammed, the torpedo would run in a circle. The modification Morrison had developed had nothing to do with the guidance system. It only affected depth control. The circular run would have happened whether the torpedo was modified or not, but Morrison still felt responsible. He'd modified every torpedo on Tang. He'd assured the captain they would work. And one of them had killed 73 men. The Navy disagreed. They awarded Morrison the Navy Cross, second highest decoration for valor. The citation praised his torpedo modifications, credited him with improving submarine effectiveness across the Pacific Fleet, noted that his innovation had contributed to sinking over 200 Japanese ships. Morrison didn't want the medal. He felt like a fraud, but he accepted it. For his shipmates, for Tang, for the 73 men who didn't come home. He stayed in the Navy after the war, served for another 15 years, trained new torpedomen, taught them about depth control, about mechanical failures, about circular runs, about how even the best modifications couldn't eliminate all risks. He never spoke much about Tang. When people asked about his Navy Cross, he'd say he was a torpedoman. That's all. Just a guy who worked on torpedoes. But other submariners knew. They knew about the depth modification. They knew it had changed the war. They knew Morrison had turned the Mark 14 from a failure into a weapon that had helped defeat Japan. At 6 o'clock in the evening on November 3, 1960, Morrison retired from the Navy. 28 years of service. Master Chief Torpedoman. Honorable discharge. He went back to San Diego. Took a job as a machinist. Worked on civilian equipment. Never touched another torpedo. He died at 2 o'clock in the afternoon on July 15, 1989. Age 79. Heart failure. Quick. Relatively painless. At his funeral, 6 submariners from Tang attended. The other 4 survivors had already passed, but men who'd served on other boats came to pay respects. Men who'd used Morrison's modification. Men whose lives had been saved because American torpedoes finally worked. One of them spoke at the service. Commander Richard O'Kane, Tang's captain. He'd survived the sinking, spent the war in the same POW camp as Morrison. Carl Morrison saved the Pacific submarine fleet. Not with heroics, not with bravery, with a wrench and 8 pounds of lead. He saw a problem that admirals couldn't see. He fixed it with tools you could buy at a hardware store. And he did it knowing that if he was wrong, he'd face a court-martial. That's not just good engineering. That's courage. The Mark 14 torpedo modification remained standard procedure until 1956. By then, new torpedoes with electric motors and improved guidance systems had replaced the Mark 14. But Morrison's principle, simple mechanical fixes to complex problems, influenced torpedo design for decades. USS Tang was never raised. It still sits on the bottom of the Formosa Strait, 180 feet down, a war grave. The Navy declared it a protected site. No salvage, no diving, just memory. But Tang's legacy lived on. The submarine sank 33 Japanese ships during 5 war patrols, more than any other American submarine, 116,454 tons of enemy shipping destroyed, a record that stood until 1968, and much of that success was due to Morrison's 8-pound modification. In 1987, the Navy Torpedo Station at Keyport, Washington dedicated a display to Morrison. It included one of the original modified Mark 14 torpedoes, complete with the lead weights still epoxied inside the nose cavity. A placard explained the modification, the impact, the results. It didn't mention Tang's sinking, didn't mention the circular run, just focused on the innovation, the problem-solving, the lives saved. Modern torpedo designers still study Morrison's approach, not the specific modification. That's obsolete. But the mindset, see a problem, understand the physics, find the simplest solution, test it, implement it, save lives. The U.S. Navy's current Mark 48 torpedo uses wire guidance and computerized control systems. It doesn't need depth weights, but it still follows Morrison's principle: correct problems at the source. Don't blame operators. Fix the weapon. And somewhere in every Navy torpedo manual, there's a section on field modifications, authority given to qualified technicians to make adjustments when official channels are too slow. That authority exists because of men like Morrison, men who broke regulations to save lives. Chief Torpedoman Carl Morrison, the man who fixed America's worst torpedo with 8 pounds of lead and changed how submarines fought the Pacific War. If this story moved you the way it moved us, do me a favor. Hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about torpedomen and submarine crews who fought with precision and determination. Real people, real heroism. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if someone in your family served. Just let us know you're here. Thank you for watching, and thank you for making sure Carl Morrison and U.S. Tang's crew don't disappear into silence. These men deserve to be remembered, and you're helping make that happen.